Chili update number 3. Just as delicious as before, however, it is a little colder. So actually going to modify this statement, not quite as delicious as before. But anyways, problem number 3. Whoa. Problem number 3 says the point -1, 4 is on the graph of f of x. So I'm going to draw myself a little graph real quick. Let's throw it on here. -1, +4. Oh, and look, I set myself up for success. -1, 4 is on this graph. And so it wants to know if f of x is even, what other point has to be on this graph? Well, if f of x is even, that means we have perfect symmetry across the line y equals x, so I have to get that point right there. If you remember the test for evenness, that test says f of x is even if f of -x equals f of x. So quite literally, even though we don't know the function, we know that f of -1 equals 4 and f of 1 equals 4. That is showing us the evenness. Now that has to be true for every single point for a function to be even, but at least it works for that point. Remember, if you want to disprove something is even, do that and show that you don't get 4 for both, or you don't get whatever the number happens to be. So let's look at the next one now. If f of x is odd and the point -1, -4 is on there, we need to get this point down here, which is not only the opposite of the x value, like our blue point up here, which went to went to +1, +4, from -1, +4. This yellow graph went to +1, -4. So notice the yellow point, which is odd, the x and the y value were oppositified, and in the blue point up here, just the x value was oppositified. So if you happen to be one of the exchange students in my class, and I just used the word oppositified, please know that that's not actually a word, and I know that it's not actually a word. It was just fun to say. But anyways, just like before, if we're talking about an odd function, our test is going to say, writing it in yellow, it's going to say f of -x. So notice that part is exactly the same as our test for evenness, f of -x, but this time we don't want it to equal f of x, we want it to equal -f of x. And again, we do have that in this situation because we have f of -x equals, I'm sorry, I want to actually put that value in there, not -x, but f of -1 equals 4, and f of +1 equals 4, so negative f of +1 equals -4. And right there, that is the test for oddness. So again, that's not enough to show that an entire function is odd, but it is a good sign that you're at least on to something.